Okay, so we're going to be working through questions 6 through 10 of the GMAT Advanced Quant book from Manhattan Prep. This is actually chapter 2, so let's get started. The first thing I do here is turn on my pen. Okay. Alright, so I would make these into integers. Now, just because we're making them into integers does not mean we're going to actually be doing the long division. That's the trap that they want you to fall in. What we're going to do is look for obvious factors, and I'd say 6 is a very obvious factor for the top one, and it was at 201. The bottom is 5 with 402. Cancels to make 1/2, and that leaves us with 6/10, which is A. Did I skip one? Yeah. Oh, okay. Okay, question 2. In a certain clothing store, the most expensive pair of socks sells for $1 less than twice the pair of cheapest socks. So most expensive is equal to 2 times the cheapest minus $1. Alright. Customer notice for exactly $18. She can buy 3 fewer of the most expensive socks than the cheapest socks. So 18 divided by m is equal to x. Alright, so this is x is equal to the cost of the most expensive. What could be the the quantity of the most expensive? What could be the number of pairs? Alright, so we want to find the cheapest ones. So we'll just we'll make this -3 or -3. So x is actually the quantity of cheap ones. Now, we have 2 equations. Well, we have one here. There's another one, right? Because we have this one. 18 divided by the cost of the cheapest one is equal to just x. So we have these two. So we can do 18 plus 18 over m plus 3 is equal to x. And 18 over c is equal to x. And then we'll do, we're substituting these numbers for x, but we still have a variable, so that's not going to work because we could just plug in any number really. So we have to substitute in, so m is the same as 2c minus 1, so that's what we'll write here. 18 over 2c minus 1 plus all that plus 3 is equal to x. And then 18 over c is equal to x. We can swap these two because basically we're doing c times x is equal 18 and then dividing out the x. So then 18 over x is equal to c. And now we can plug in values for x, right? Because now there's only one variable in this one. So let me just rewrite that one last time. 18 over 2c, so 2 times 18 is 36 over x minus 1. All that plus 3 is equal to x. Oh boy. This is so messy. Sorry about that. Alright, let's try 3. So 36 divided by 3, 12. 12 minus 1 is 11. 18 over 11 is not an integer, so that cannot be an option because we're talking about socks. You can't have like 2/4. I mean, you could, but GMAT's not going to do that. So not 3. 5. 36 divided by 5. Nope. Not an integer. 36 divided by 6 is equal to 6. Minus 1 was 5. 18 does not work. 36 divided by 12 is 3 minus 2, or minus 1 is 2. 18 divided by 2 is 9. 9 plus 3 is 12. And x is equal to 12. So that one works. Not even going to bother with E. Alright, perfect. Okay. Next question. Alright. I think the easiest way to do this problem is to just plug in the number. So we know off the bat C is not going to work. 0 cannot be the denominator here. Let's do -2. So 3 and then -2 plus 1 is -1 over -2 plus 1 is equal to 1. Alright, so we're going to have 1/2. 3 divided by 1/2. Right? Well, this is actually, sorry, 1 1/2. So that's 2. Does not work. 3, oh, we're going to have 0 on top. So 3, and then -1 plus 1 is 0 over -1 plus 1 is 0. So that's not going to work either. All right. 1. So 3 over 1 plus 1 is 2 over 1 plus 1 is equal to 1. All right, so this is 2 plus 1 is 3. So 3 over 3 is equal to 1. Yep. All right, so we're good there. All right, so for some reason, yeah, this book, or sorry, in the book, this one does not have answer choices. So on the GMAT, you won't get a problem like this. But let's see, what do we have here? Basically, for these, we want to write them out in their prime factors. So 35 is 5 times 7, and we have 3 of each. All over 72 is 8 times 9, and 8 is 2 to the third times 3 squared. And all of that is over 7 factorial, 3 factorial, 4 factorial, all of it cubed. So let's see, we have, so 7 factorial divided by this. So basically 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. But we know that 4 factorial is, so basically this is the same thing, right? So we can cancel this with all of these. So now we're left with 7 times 6 times 5 over 3 factorial. 3 factorial is just 3 times 2 times 1, which is just 6, right? So we can cancel all the 6's with 3 factorials. So now we're just left with 7 cubed times 5 cubed. And this is all over 1. And then up here we have 2 cubed times 3 cubed, or squared, 5 cubed times 7 cubed. Alright, so it's a fraction divided by fraction, so it's basically the same as doing multiplication. This looks confusing, but so let me get that out of the way. So this cancels out with these, and we're left with 1 over 2 thirds, 2 to the third times 3 squared, which is gives us back to this 72. So our answer is 1 over 72. All right, last problem. So for me, when I plug these in, I think it's probably, if I just factor them, right? So if you just factor out 3x, you're left with 1 for each of those. Equals 1, right? And this is equal to 3. So 3 times 3x is equal to 1. Or, now we want to get that by itself. So we get 3x is equal to 1/3. And 1/3 I know is equal to 3 to the negative first. Right? Because any number to the negative first is just itself under 1. It's reciprocal, basically. So that gives us x is equal to -1, which is a. Alright, so let me check the book real quick this time and make sure the answers are correct. Chapter 2. Whoops. Question 6. So question 6. Alright. A. 7 is D. Okay, also right. 8 is D. Alright, we're good. 9 is 1/72. That's what we have. And 10 is A. Alright, perfect. Alright, there we go. Hope that helped.